All right, welcome back everybody. We have another shape to talk about today, and that's called a kite. And so on the agenda today is a definition of a kite, two theorems about a kite, and three examples that go with it. So let's start with the definition of a kite here. A kite is a quadrilateral, so four sides again, a quadrilateral with exactly two pairs of congruent consecutive sides. So you see side AB and side AD are congruent, they're consecutive, they're next to each other. And then a different pair of consecutive congruent sides. So side BC and side DC are congruent and consecutive. So you can see that it does look like a kite. But that's your mathematical definition. Okay, so the first theorem we have regarding a kite today is that the diagonals of a kite are perpendicular. The diagonals of a kite are perpendicular. So if you look at that drawing, we have kite A, B, C, D, and you see the diagonals drawn in there, and we're trying to prove them perpendicular. So we're trying to prove that segment BD is perpendicular to segment AC. And we're going to be able to accomplish that with one statement. So you got to reach back a little bit and remember the theorem that we had a while back. It says use the theorem there. If a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector of the segment. So if you focus on point A right here, that point A is equidistant from the endpoints of segment BD. You can tell by the two double marks there. And also point C is also equidistant from the endpoints of that same segment BD. You can tell by the two single marks. So the fact that points A and D are equidistant from the endpoints of segment BD means that they lie on the perpendicular bisector of that segment. So that tells you that segment AC connecting points A and C is perpendicular to segment BD. So that means that the diagonals of a kite are perpendicular. Okay, our second and last theorem today is the following. Exactly one pair of opposite angles of a kite are congruent. Exactly one pair of opposite angles of a kite are congruent. So in the figure you see there, you're trying to prove that the pair that are congruent are K and M. We're trying to prove them congruent. And at the same time, we're going to try to prove that the other two angles of the kite, so namely angle KJM, which I'll highlight here, trying to prove that this angle right here is not congruent to KLM because you only got one pair of congruent angles here in a kite. Okay, so the way we're going to do that is, first of all, to prove for the first part here, we're trying to prove right here that angle K is congruent to angle M. We're going to say that segment JL is congruent to itself. And so you can see the top and bottom triangles are congruent by SSS. And once those two triangles are congruent by SSS, we know all their corresponding parts are congruent. So now we can say that angle K is congruent to angle M by CPCTC. Corresponding parts are congruent, triangles are congruent. So that tells you that that's your one pair of opposite angles in a kite that are congruent. Now, to actually show that it has exactly one pair, we have to show that the other pair of opposite angles are not congruent. Okay, so the way we're going to do that is to, let's see what I'm going to do here. Let's see, erase some of this. We're going to say, well, let me get rid of this right here and mark these off that we already said are congruent. So we're going to use that method, that indirect proof that we talked about earlier in the class, which is assume the opposite of what you're trying to prove. So assume that angle J and angle L are congruent there. If that's the case, then you have both pairs of opposite angles of a quadrilateral congruent, and that would make that a parallelogram. And so that's not a parallelogram, that's a kite. So our assumption is false, and it must be true that only one pair of opposite angles of that kite are congruent. So after all that, we can conclude that exactly one pair of opposite angles of a kite are congruent. Okay, let's talk about our last three examples related to a kite. So if you look at figure quadrilateral EFGH, that's given to you to be a kite, and then they want us to answer the 3 questions in blue. So first we want to find the measure of angle GFJ. So GFJ, so that's this angle right here. Now remember that one of our first theorem today was that the diagonals of a kite are perpendicular, so we know that these are all right angles here because the diagonals of a kite are perpendicular. So that means that this angle GFJ that we're looking for is going to be the complement of this 57-degree angle. So you're just going to take 90 minus 57. So just do that mental math or calculator, 90 minus 57. So this is going to be 33 degrees right here. Because that 33-degree angle and the 57-degree angle have to be complementary because you've already used up 90 degrees for the right angle. So 33 degrees. Got that one answered. Next is to find the measure of angle JFE. So JFE, so it's going to be this angle right here. And we're going to use the same strategy there. You got that triangle here, that triangle FEJ, and it's also a right triangle. So we're just going to take 90 minus 25. So this angle is going to be 65 degrees right here. For the exact same reasons before, those 2 angles, the 65 and the 25, have to add up to a right angle because you've already used up 90 in that, out of that 180. So this is going to be 65 degrees right here, this angle JFE. Okay, now I'm going to erase some of the clutter in this diagram because we're trying to find, actually I may not have to, we're trying to find the measure of angle GHE. So this angle right here, I'm going to make that yellow, and GHE. Trying to find the measure of that angle. So that's an angle of a kite. Remember, our second theorem today was every kite has exactly 1 pair of opposite angles congruent. So the angle opposite to that is then going to be, let's use a different color here, it's going to be this one. So that angle EFG, once we find out what it is, it's going to be the same as the yellow angle EHG. So all we have to do then is add up the 65 plus the 33. So it's going to give you 98. So 98 degrees for that purple angle. But remember, each kite has exactly 1 pair of opposite angles congruent. So that means the measure of the angle GHE, that the yellow one that we're looking at, is also 98 degrees. Okay, so let me summarize what we need to know about a kite. First of all, a kite is a quadrilateral. It's got 4 sides. And it is, by definition, a quadrilateral with exactly 2 pairs of congruent consecutive sides. So the consecutive sides are congruent. There's 2 pairs of those. We need to know 2 theorems about a kite. The first theorem says that the diagonals of a kite are perpendicular, so that's going to be important to know. The diagonals of a kite are perpendicular. And the second theorem that we need to know about a kite is exactly 1 pair of opposite angles of a kite are congruent. Okay, so that's the information you need to know. Let's take a look at the assignment that goes with the kite here and start that. So enjoy and good luck.